Hello out there, Internet, and any people who may be interested in watching this project and maybe even following and supporting it a little bit. It's Amin Gecko here, and I am going to be putting together a little game. It's going to be an endless shooter based off of the same concept as the Infinite Driver for the mobile games that you can find everywhere. You know, it's beach buggy rally or something like that on the Android, and there's various different versions used for different OSs, but it's all basically the same thing. You're just driving on forever and just trying to collect as many coins as you can for upgrades and such like that. And this game's going to be based basically around the same idea, except you're going to be at the bottom of the screen. You're going to have boxes falling down towards you, and then you're going to be shooting your way through the boxes in the attempt to survive for as long as you can. So, let's see what all we have here. Now, you'll notice I have a lot of pre-written code in here. This is because this is stuff that I use very frequently. It gets very repetitive, and I tend to forget to commentate while I am busy doing this. So, now the language, in case anybody hasn't figured it out already, the language is going to be in C++. We are going to be using the SDL, or Simple Direct Media Layer API, or libraries for this. I have SDL included here, and you'll notice I have SDL GFX, which is short for Graphics Primitives. This allows me to simply draw shapes using code, and I don't have to use my terrible hand at attempting to create terrible artwork. And this artwork may actually come in down the line, but as of right now I'm not terribly worried about it. You'll also notice I have this boost library in here. This is simply a very efficient and very easy way of doing resizable vector arrays, and I know most people know about the vector library that you can just include vector for that. Well, that particular container doesn't work well for classes. Boosts does all the extra legwork internally needed for the classes, and it's actually been all the places I was looking for it when I was researching this stuff. The boost library was actually recommended over the standard one, so that's why I'm using that one. We've got our box class here, which is going to be the boxes, falling from the top of the screen down toward the bottom of the screen. The player, of course, you're going to be down at the bottom, shooting up at the boxes and destroying them as they come down. We have the bullets, because we're going to have the bullets being tracked to see if they hit the boxes or not as they're falling. It's still very much incomplete, but I got the tedious stuff out of the way. So here we go to the main screen. Of course, first thing you do is you initialize SDL, which is this line here. Initialize everything, just because we may need everything, or the grand majority of it all. Now this here, this constant SDL video info pointer, and this function here, what this does is this actually gets the native information of your monitor as it currently sits. Now what this then allows you to do is you are then able to just pull someone's desktop resolution. It pulls their monitor resolution natively from the system. That way they don't have to worry about things being changed. This also keeps me from having to lock the resolution in at a certain size during development, and I've been wanting to play around with this anyway, so that'll be handy for me. We set the screen size, and now you'll notice I have a buffer set here. Now these two are global variables that are declared up at the very top of the main.cpp. If you'll notice, I have them declared up here. These are the main.cpp. These two are globals. Now this one is also considered a global variable, but this is a global compile time variable. Now, with C++, that's one of the biggest differences between that and many other languages. Everything marked with a hash sign in C++ is a compile time parameter. These are things that when you build the project, that's when these things become relevant, and then those values are then inserted everywhere else throughout the project. It's handy when you get into bigger projects to have these things when you have a lot of people involved, because sometimes you will have that one guy who decides it'll be funny to sabotage your primary frame rate and cap the thing at 12 hertz rather than at 120 hertz, or frames as it is in this instance. The hertz is just simply the same idea. It matches the frequency of your monitors if you can get up that high. The game I have this capped to run at 120. Just doing that there is kind of a thing to test my regulating statement down here. In all honesty, I don't think this game is going to run at anything less than probably several hundred more if we were to disable that cap. But sometimes you do have a problem if you don't cap it at some point. Especially with 2D stuff, it's going to be running so fast it can't get to the screen in time to be able to process everything, or it won't wait for the render to finish. That's another problem I've run across. Now, is this the case with SDL? I'm not sure, but I still do it just to be certain. Just to be absolutely certain. I have the event structure here. And then we have this keys array. Now the reason for this keys array is because SDL only detects an event when that event happens. What do I mean? You press the button down, it detects when you push the button down, it detects it again when you let the button up, but if you hold it, it doesn't register an event change. That is what this Boolean is here for, and the 323 I believe is the same. It's needed so you have the same count as in the key symbol enumerator, I believe it is. The key symbol enumerator for the keys structure within the event SDL event lineup. And the 323 different members of that all correspond to one of these Booleans. And when those Booleans are set to true, that is then when when those Booleans change. Let me back up a little bit. When the Booleans change, that is what we want to look for. So we will be checking the state of these Booleans, and we'll be writing that function in here later. Here's where I use the pointer vector. It is for the boxes, or foes, as I have them labeled here. The reason why I want to do this is because more and more boxes are going to be falling towards you as you are at the bottom of the screen, and as more boxes keep falling, we need to be able to keep expanding this array, and so that's why I'm busy using the pointer vector right here. Player is of course you're going to be the player, or the player will be the player at the bottom. Bullets, which is the shots, that's how many times you can shoot at one time. Now what will drop this, I have a maximum of 5 shots that you can shoot at any one time on screen. The bullets are going to be traveling really quick, so I don't think this should be too much of a bottleneck, but if it is, well, that'll just add to the challenge of the game. We want to have something for this to be at least something of a challenge to try and keep things interesting for a little bit, despite the fact that probably most everybody has clicked off of this video by this time. And then I have this down here, which is simply a testing statement to just see if I can get this thing to regulate the frame rates based off of what I have this number set to. Will this work? I'm not entirely sure. Now, one of the things you will notice, if any of you have done any kind of programming in the past, I am missing my primary game loop. And the reason why I'm missing my primary game loop is because I wanted to do that on camera and see if there is anything interesting that you guys might have to add before we go in too far into this. So that's everything for now. We'll start writing the code when we actually get into the next video, and I will see you then.